Hey everyone, it's Professor Lamb, and we're going to do a CodeAlong for at least part 1 of the Gradebook assignment. So I have it open here, and why don't we go ahead and jump to the data loader class. And the first thing we need to do is generate an int of size 10 containing 10 random grades. And I asked you to use either math.random or java.util.random. So let's do java.util.random, which entails creating a random object. So we'll just call it random. And we're going to need to iterate 10 times. So let's create an array of size 10. Oops. And let's create a for loop to iterate. We can go ahead and put results here. Alright, so 10 times we need to invoke a method on our random object, and we can do next int with an origin and bound. Or we could just do this one works. So it's exclusive of the upper bound, so we would want to make that 101 if we're including 100. And actually we want to insert that into our array using this counter. Okay, and that should work. So let's see what we need to do next. While we're on this method, though, I do want to just tell you that this would be like an interesting case to use a stream, since we're learning a bit about streams moving forward. And streams make things a lot easier. Like, I don't have to remember to count to 10 and, how to avoid going over by 1. And so let's just take a look at what that would look like real quick. So the random class actually has a method in it that generates a stream of integers. So we're going to return the stream after we reduce it to an array. But what this would look like is random.ints. You can see here there's an int stream, and we probably want to use this third option. So we set the size and the origin. Let's see, and then it's exclusive of the upper bound again. So we would say we want 10 numbers, 50, 100. And now we've created a stream of integers. The only catch is the streams work on reference types, not primitives. So there's going to be some auto boxing happening when we call toArray. Let's see if it takes care of that automatically. And it seems like it does. So this, look, we did in 2 lines of code, and I think this is a lot easier to read personally. We did what would have taken 5 lines of code. So streams are cool. If you take more developer classes, you'll get real familiar with them, and you'll start to prefer them over, for loops. So let's move on to, I think we want to go to Gradebook next. Okay, so we need to implement all these methods in Gradebook before our main program will run. And we have a list of students. So this seems pretty straightforward. All we want to do is add this student to our list. Get a list of all students in this Gradebook. That's implemented for us. Calculate the final grade of a student. And use math.seal. And I assume it wants us to get the average of all grades. I guess we're not doing a weighted grading scheme at all. And just to note, so when a student is created, the constructor is called, which creates a grade map in every student. And so the question is, when does the grades, the value, not the key, when do the grades get assigned to this hash map? Because it doesn't, it does look like it could be in this constructor. So that might be something we want to do, because I doubt the main program handles it. Oh, I bit my own tongue. It looks like we are supposed to do it here in the main method. Yeah, so we'll do it there instead of in the constructor, like it says. So let's just keep going. We'll assume that since there's a load step, that we'll just assume all the grades have been loaded in the grades map for each student. So we need to iterate over each grade in the grades map. So we want the values. We can do an enhanced for loop for that. This might be another good stream opportunity. But I'll just do an enhanced for loop. So for each integer grade in student get grades, and then we want the values. So we'll just do that. We will add them all up and then divide by the number of grades, which we know is 10. So let's get a total accumulator variable here. So we're going to return math seal of the total divided by 10. And it says we need to cast this as an int. Beautiful. Implement a method to print all students and their final grades. Okay, so we need to iterate over our list of students for each student in students. Let's see what 4-string or 2-string method we have here, if we have any. It doesn't look like we do, so I might prefer creating a 2-string method in student that I can call here for this. So we can do that by going to source, generate 2-string, name grades. I think it just said grades. Let me double check that. Oh, we're just printing their final grade. So we don't even have to use that 2-string. I'll keep it just in case. I'll put it down here at the bottom. So if we just need to print out their final grade, let's get their name. And we'll do a colon followed by their final grade. Actually, we need to call through to our calculate final grade method here. And it will automatically convert to a string. So that should work for that. Then we need to retrieve a list of all students with a final grade below 70 and return it as a list. So let's create a new list first. Let's just use an array list. Oops. And we'll iterate. Although this is a great place to, let me show you all something. I think we could do this in one line of code. So you could iterate over the list of students and if their final grade is less than 70, add them to this list and then return this list. So feel free to do that. Or to learn about streams, and this shows you just how powerful streams are. You can go students, stream, filter. So a filter selects students based on your condition. And so you kind of have to write a condition in the parentheses here. And you use a lambda to write that filter condition. It says it accepts a predicate function, and so lambdas are kind of like special syntax for any Java function that has how does it put? It's any Java class or interface that has a single abstract method. If there's ever a Java interface with a single abstract method, you can use it to write a lambda. And so Java actually creates all of these funny function classes like predicate, consumer, supplier, operator, function for us. So we need to write a predicate class here, and we do that using a lambda. So a lambda is technically an anonymous class. So I tend to like writing X. X in this case would be a student. To make that abundantly clear though, let's write stud. And then we use the lambda arrow, and we go, we want a Boolean here. So the Boolean expression would be calculate final grade. Let's just call him Stu, or her, Stu. Calculate final grade is below 70. Okay, so that's our lambda. We just wrote a lambda. Congratulations, everybody. But we're not quite done yet. We need to, call toList, which is a reduction operation. And that is that. So until you do a call to one of these terminal operations, you still have kind of you think of it as a flowing stream. And the reduction here, we saw it with toArray. These are the terminal operations of a stream pipeline that activate all the intermediate operations. And I don't know, I kind of think of it as like they call it a wave function collapse to take a metaphor from a different field. So this takes the dynamic streaming pipeline and makes it like it returns the static result, which in our case is going to be a list of students with a final grade under 70. So just to show you how confident I am that this works, we're getting rid of the other option. And you can write streams like this in almost like any situation. They're really versatile, really powerful. Definitely worth your time to learn how to do them. And this is another great place for a stream. The other nice thing about streams is you can do them in pretty much one line of code many times. we want, the only thing tricky about this is we'd probably have to write a custom comparator, which gets a little hairy sometimes. But let's see. So a comparator, you could do it, you might be able to do it as a lambda, but I'm more familiar with the anonymous way, the anonymous class way of doing it. New comparator. And then we have to override the compare to method. So let's import that, add unimplemented methods, and there it does it for us. So object 1, object 2. These are students. I wonder if we needed to hang on 1 second. I just need to see something. Yeah, so comparator, it looks like it's a generic, so we just need to put that generic in there first. And there, yeah, that would have caused a lot of problems with needing to downcast. Okay, and then so for comparator, we go if calculate final grade, and let's call these S1, S2. Is less than S2. This would be in order, the order we expect. Return -1. So if S1 is less than S2, return -1. And then we just need to flip that around and return 1. If S2 is great, no. If S2 is less than S1. And this probably should be a else if, and then else here. Okay, now why is it screaming at us, right? Oh yeah, okay. So we still need to do another. Let's make this a little neater so you can see what's going on. So we still need to do another terminal operation. Not a terminal operation. We need to do an optional method. So we do get, and this is because the max intermediate operation, the max terminal operation returns a optional student. Optional is a really important class to know about, but Might be a little above the level of intermediate Java, but it's good to know about. So we're calling a method of the optional class, and you can do get, but get always throws an exception if there's not a candidate. So often people do if present or else is present. And you can do or else. But there should always be one student with the highest score, unless there were a lot of students with the same score. But even then, I think there would still be, it wouldn't be null. So let's do get. Okay, so probably would have been easier in that situation to iterate classically, but since I did all that work, you can keep it. And sometimes I have been known to get mixed up with the order here, so we'll have to check that. And, we might as well just copy and paste this since we did all this work. We'll just need to change one thing pretty much. Can you guess what the one thing is we need to change? We're going to change this intermediate option to min. We can keep the comparator the same. So in this case, that's a lot of code duplication. We would want to actually create a custom comparator. Probably in the student class. I wonder if Eclipse sometimes gives us the option to extract it. So you see I went to refactor, and there's a convert anonymous class to nested. So what is the type name? Type name. I guess we'll call it student comparator. And then we can do the same thing here. So we do it from here to here. Now what's the student comparator? Where'd that go? They stuck it way up here. That's not cool. So we got a nested comparator class, but I'm going to stick it at the very bottom. And it would probably be smart to, well, I was thinking we could unnest this, but I guess it's fine having it nested. Okay, so we cut down on that duplication. Now those methods look a lot better. And we're going to hold off on the attendance stuff. That's going to be part 2 of the video. So let's save everything. We'll hold off on that for part 2. Making sure I got everything. Get grade, set grade. Set all grades of a student at once. Okay, I see what the confusion may have been about here. So the key, when it says set all grades of the student at once with the given key, yeah, I could see how this would be confusing. So the key is the string, and the string is here. Okay, so let's see. Set all grades of the student at once. And we're assuming that's the data loader. This is the array of 10 random grades we created from data loader. So there may be an issue. I'm going to pause for 1 second. Sorry about that. That was a food break. And so now I can think again. And it was a good food break because I thought about this giving key issue. And I think the trick here is we just need to iterate over the grades map in general. And then, obviously there's no key set yet, but there will be, when the program runs and when a student is created. Anytime a student is created, it's created with this grades map, and that grades map is initialized as a hash map here in the student constructor. So every student object comes with a grades map that has these keys already set. So we can iterate over all of the keys and values of this map using the entry set method. So we have to use a peculiar map method here that, well, I mean, it's actually pretty common, but it looks a little funny at first. So we want to write a enhanced for loop, and this is one of the few places I think it's appropriate to use var as the type declaration. I'll show you what I mean. So for each var entry, or we could call it for each grade of grades dot, and here's where we do entry set. So we need to use this method. We saw values already. Values would iterate over all the grade int values. Key set would iterate over the keys. Entry set iterates over the keys and the values as a pair. So think of entry set as iterating over the pairs, the key value pairs that make up a map. Now, I said it was okay to use var here, but it's probably better to use the actual type declaration. var is a new syntax thing that irks a lot of Java developers because I don't know, it kind of makes Java look more like JavaScript or Python. So you don't really see the type declarations up front. You just rely on the compiler to infer the type of grade. Okay, so what is the type of grade? It's this crazy thing called a map entry. And you have to put in the type values here for the generics integer. So that's the other way of doing it. You can see why var is a little easier to read, a little more concise than that, but we'll keep the full type declaration. Okay, and then so for each, we have a grade. So all we need to do is, let's think about this. We want to set value. Which means we also need to iterate over our int. So let's create a counter. And we will use the counter here, int r, and then we need to iterate that counter. I'll just do it like that, or you could do plus equals 1. That's the same thing. So that's actually how to implement this set grades method. It's a little tricky because of this method mainly. Also, the iterating over the array could be confusing at first. So I think that's probably going to be it for part 1 of this already long video. But let's at least, well, actually, we can at least do the first few menu options here. Okay, so we need to add students. Okay, so this will show us, we can at least get through a few of these. Okay, so we're going to add 8 students. Oh, and we can do that. Oh, I see. So we're getting the user input for that. My bad. So we got a string name. And where's our gradebook? Oh, right there. Add student. Okay. If you spend much time online, with competitive programming. For some reason, people always just love to make things as concise as possible, but it doesn't matter how you do it. All of both those options are fine. But I can see the appeal to this, to adding the student one and the same as creating that new student. Kind of makes sense. Okay, so here is where we generate grades. And this is where we call our set grades for each student. So we're going to need to iterate over our list of students in Gradebook, which is private, so we need to call, we need to get students. Oh, here it is. So we do have the getter for that list collection. So let's do get students. And then, so we'll get the students. And then we have okay. So let's do it this way. For each student, in Gradebook, get students. Here we can call set grades. And we're using our data loader. Do we have a data loader? Doesn't look like we have a data loader, so it's probably a static method. So let's call a static method. And that is that. Show final grades. So we already have a method for that. What was it called? Print something? Print Gradebook, I think. And we can at least get 4 and 7. 4 and 7. Show students in danger of failing. For each student in Gradebook, get failing students. Let's just print out the name of that student. Let's look at show best and worst final grade, which is number 7 here. Student with lowest grade. Let's put a space here. Oops. Alright, so let's see if any of this works. I'm going to name my students capital letters. A, B, C, D, F, G. And we're going to load grades. There should really be a confirmation for that. And let's show all the final grades. Nice. That's pretty cool. So there's 2 students that should be in danger of failing. Yeah, that looks right. D and G. And let's see if my comparator was correct. The moment of doom. Oh, and we used our 2 string here. So the grade, saying the student with the highest grade is C. Lowest grade, G. That seems very likely. Yes. All right. Well, so that is the end of our Part 1 CodeAlong. I hope this helped. And so go ahead and try to implement these 2 menu options. Hopefully it clicked by now. To do these, you'll need to implement some methods in Gradebook and Student. So you can create your own methods to help with this in the student. And I guess just a word on that. So the attendance field here, every student has an attendance. Attendance is a collection of dates, and that number of dates that's included is out of 15. It's also randomly generated, but I wrote that code for you. So it's every student is going to have between 5 and 15 dates that they were present. So to calculate like how many absences there were, you would need to get the number or the size of this attendance set and then subtract it from the number of total classes, which is 15. So it'd be 15 minus attendance.size. So that would be how to calculate attendance. I hope that helps. Okay, thanks everybody.